Okay, so this is the Pert practice test, and we're going to do questions 23 through 26. So number 23, solve the equation. And when you have something like this and it says the word solve, we want to try to get like an x equals something. That's what pops up in our brain, or a variable equals something. And even our answer choices are x equals something. So how do we get there from here? Because x squared, there's no like terms here. We can't simplify. So we're going to have to kind of throw out the multi-step equation steps. And so let's think about what this looks like. Well, we have an x squared, we have an x, and a constant. The form that this is in is a quadratic. And so if you think of quadratic, I think of factors. So we're going to go ahead and factor this to make it so we can go ahead and set them both equal to 0. So when we're factoring two things, there's multiple ways to factor. However, I'm going to show you one of the methods that I have done. It is not the only method. There are multiple ways to do this. So if you have another system, that's perfectly fine. So what I do is I set up my factors here, and then I make a t-chart. So it's just a habit of mine. So in my t-chart, I know that I need to find two numbers that multiply to be something and add to be the other. So they need to multiply to be the outside number, and that's going to go here, and they need to add to be the inside number, and that's going to go here. So when I do this, so they need two numbers that multiply to be 24 and add to be negative 10. Well, there's a bunch of numbers that can multiply to be 24, and you might have already known the two that we're going to go with, but let's go ahead and just, if you didn't, take a guess. So 24. So we could have done 2 times 12. Oops, sorry, 12. But when I add 2 and 12, I get 14. So that doesn't help me with the negative 10. So that's not the magical pair of numbers I'm looking for. So let's do 6 times 4. That's 24, right? But 6 plus 4 is 10. That's super close. However, I'm looking for a negative 10. Well, there's other ways we can get to a positive 24. What if we did negative 6 and negative 4? That'll get me a negative 10, and they both multiply by 24. So this is my magic pair. So I'm going to write negative 6 and negative 4. So now that I have my factors, okay, now in order to solve them, we're going to set each of them equal to 0. So we're going to start with x minus 6 equals 0 and x minus 4 equals 0. Well, we're going to add 6 over here to both sides, and x equals 6. Add 4 to both sides to get x by itself, and x equals 4. So it's this one. Now, think about it though, because if you didn't, I always put the parentheses first to let you know they're still factors. So when we put in this negative 6 and negative 4, that is not our answer, right? We need to set each of those equal. So these are factors and these are solutions. So that's why we have something like this. So when it says solve, that's what we're looking for. Okay. So let's do this one. So it looks like we're doing what we did in the past, which is divide polynomials. And it's kind of similar. However, if you look at this, we can't really do this so much because these are going to cancel each other out. And so are these. They're just not matching. So if you come across something like this and it's just not adding up the way you want it to, start looking at the different forms. So the first thing I noticed is that both the top and the bottom are quadratics. So if they are quadratics, I can factor them. So I'm going to go ahead and try something different. So we're going to go ahead and factor the top and the bottom to see if we get something else. So let's go ahead and just factor the top one first. So in the past example, I did show you my t-chart. I do like my t-charts. Again, it is not the only way to factor. You can totally factor other ways. This is just how my brain processes it. This is how I've taught my class in the past. So I need two numbers actually that multiply to be 4 and add to be negative 4. So numbers that multiply by 4 are pretty easy. It's 2 and 2. However, those give me a positive 4, so that tells me that I need to do negative 2 and negative 2, and that'll be the right one. So negative 2 and negative 2. So I'm going to go ahead and factor the other one. So I need two numbers that multiply to be 6 and add to be -5. So the first thing that come to my head again are 2 and 3. However, that gives me a +5, so that's not going to work. But -2 and -3 will give me a -5. So that's supposed to be 3. So these will work. So let's go ahead and put in -2 and -3. All right, so now this is pretty easy. Now we can just go ahead and cancel the things that cancel. So x squared or x minus 2 and this x minus 2 cancel each other out. And we're only left with this x minus 2 and x minus 3. They don't cancel each other out. So this would be your final answer. So for number 24, your answer should be D. Number 25, so we're going to switch gears. We're going to go into radicals. So in order to do this, it's pretty easy. There's multiple ways to do this, of course. However, I'm going to show you how to just build a straight up factor tree. That's probably the easiest way I know to go about it. So we're just going to break this down. Let's just do the square root of 27, right? We're going to break this into the 27 and then A and then B. Okay, so the rule of thumb when you're trying to find your final answer for this is that, actually, let's actually write it down here. When you're trying to find your radical, in order for something to come out of the radical, it needs to come into out in a pair. So what I mean by that is let's think of any two numbers that multiply to be 27. We need to break them down into factors as far as possible. So we have 9 and 3. Well, 3 I can't break down anymore, but 9 I can break down into 2 more 3s. All right, so we're looking at this. So I told you that in order to come outside of a radical, it must come in a pair. So this number 3, these can come in a pair. So they can come out. And then this number 3, he's stuck. He doesn't have a pair to exit with, so he is going to stay inside the radical. Now I know I took out 3 pairs, but it's almost like when they come together, they just become like a couple and they become one. So they're going to go right into here. So now we just did 27. So I am going to erase this just so I can make it look prettier. So let's go ahead and do the square root of a to the 8th. So a to the 8th, right, is just 8 a's. So 1, 2, 3, 4, 5, 6, 7, and 8. So when I go in, I'm like, all right, well, how many pairs can I pull out of this? Well, I can pull out 4. So a to the 4th, and there's actually none left in there. So because they all come out so pretty together, I don't have any a's in the radical. So we talked about test-taking strategies in the past. So before I even go forward with going ahead and doing B, we can look at B and D. They still have A in the radical, so they definitely can't be the answer. So just so you know, so we already could have gone and done half of the work. You know what I'm saying? You bring it down to 50-50 chance. Let's go ahead and do B to the 7th. So again, this is just 7 B's. B, 2, 3, 4, 5, 6, and 7. So how many pairs can I pull out? 1 pair, 2 pair, 3 pair, and 1 left over. So 3 pairs and 1 stuck inside. So your final answer should be A. But again, we could have eliminated B and D and gotten down to that if you were doing a test-taking strategy. So let's do the last one for this video, which is number 26. So again, we're completely switching gears. This is not what we've been doing in the past. This is solving for a variable. So we're going to switch into our multi-step equation steps. So it says solve the formula for, this is a equals 10 plus ry, and it wants y. So I'm going to go ahead and write it over here just because it's easier for me to write. So if solving equations comes easy to you, then this is going to be pretty easy. You're just going to move stuff around. But to understand something, you are going to get y by itself. However, we're not going to be getting rid of this a or this r. They can't just disappear. They're not going to combine. So having this in your head that it's not going away, they're just going to go to a different place. is helpful in a literal equation. So if multi-step equation is just not something for you, this is kind of how I envision it. This is very elementary level of this. It wants y by itself. So I put y like in a bubble. And then I'm going to draw bubbles around the things that are also on the same side as y that are not supposed to be, because it's supposed to be by itself. And I'm going to do these bubbles as based on how close they are to y, right? So this r would be the next bubble, and then this 10 would be the last bubble. So if you're trying to decide, well, what do I do first? When you're trying to get y by itself, we need to kind of pop these outer bubbles first. So let's go ahead and eliminate that 10. Well, the inverse of just having 10 to it would be subtracting 10. So let's subtract 10 from both sides. I also highly recommend when you're doing literal equations, you truly do one tiny step at a time. So on the right-hand side, they'll cancel, and we just have r and y, r times y. Over here, we have a minus 10. We can't combine them. They're not like terms, so they're just going to stay the way they are. Now, it still wants y by itself, so you have to figure out what's currently happening in order to do the inverse. What is currently happening is this is r times y, so we need to divide both sides by r. So those go ahead and cancel, and we have y equals. Now, all over here, we have a minus 10 over r. None of these are like terms or anything like that. So they have to, this is as simple as it's going to get. So your answer should be A.